Okay, good morning, good afternoon, everyone. Thank you very much for joining us for this LAB2FAB virtual seminar. So LAB2FAB is a workshop that's going to take place in September in Whistler. And leading up to it, we've been hosting several virtual seminars. And today's seminar is going to be moderated by myself, Lucas Rostowski. I'm a professor at the University of British Columbia. And we have three guests today, Ben Wiltshire from Zynate, Martin Laforêt from Quantum Sherbrooke Innovation Zone and investment firm ACET, and Pinder Dasange from UBC from the Quantum Collaboration, which is UBC, Waterloo, and Sherbrooke. So a few words about what the LAB2FAB workshop is about. So this is a platform for industry and academics and governments to collaborate and discuss and overcome research and development challenges in building products that require manufacturing of microsystems. So our goals are to build capacity and expertise so that we can be competitive in Canada in this field. We believe that nurturing partnerships is a good way for Canada to work together to achieve these high-value outcomes. And we also want to align the priorities among all the industry and academics so that we're working in a common direction. One of the focus topics this year is going to be on photonics. And so specifically, we want to look at a topic called photonic integrated circuits. And we have a flourishing Canadian ecosystems. So at the workshop, there will be some speakers discussing what this integrated photonics is all about. And this will be from academia, government, and industry. We'll talk about both the photonic design and the fabrication opportunities that are available in Canada. And it's an opportunity to network with people in this field and learn about this exciting direction. One new program that we're introducing this year is called the Rising Stars program. So this is to encourage graduate students to get involved in the workshop. And the idea is that we're going to identify some of the most promising emerging talent in Canada and invite them to come to the conference. And so the idea is that these will be by invitation by faculty supervisors or another participant. And the idea is that we waive the registration fee for these promising students to be there. We'd like to thank our sponsors. So we have two industry sponsors, Lucida and Aponics, and we have a variety of academic partners. So these are institutes and universities in particular who have nanofabrication facilities that are coming to the workshop. So I'd like to kick off the seminar today, and we'll have three talks, each about 15 minutes. From Ben, Martin, and Pinder, and in the middle we'll have also a discussion, kind of a moderated discussion. So first, let's start with Ben. So Ben joined Zynate, which is a company working on heterointegration. So he joined in 2021 as a senior engineer, and he's working on testing and modeling devices at the nanoscale. He graduated from the University of Alberta and UBC in 2022. On microwave sensors with a special interest in semiconductor materials. And he was awarded an NSERC CGS scholarship, and he has published over 30 papers in journals and conferences. So welcome, Ben, and thank you very much. And I'll hand it over to you.
Thank you very much, Lucas. I will set up a screen here for everybody.
Good.
And hopefully start playing. Yeah.
Perfect.
So thanks everyone for being here today. It's nice to see people interested in technology development here in Canada. I'm happy to introduce this presentation covering how Zynate is pioneering the new frontier of Moore's Law and how Canada can participate at the leading edge. So just thanks for the introduction. I'll just say I'm a senior engineer here at Zynate. We're a technology company aiming to change the way we envision and build microchips. Before Zynate, I studied at the University of Alberta and the University of British Columbia on the topic of microwave frequency sensors with a focus on semiconducting materials. At Zynate, we're a young company, just launched late 2021. late last year. But we have a lot of things in our favor. We have a motivated engineering team that's constantly growing. We have investor interest as well, as you can see. We have a nice mix of young talent as well as industry experience that you can see along the bottom. And we're building the workforce required for the future semiconductor and electronics industry. So what is this future? Well, to put it in perspective, I think look at Moore's law. So it's very impressive that for over 60 years, transistor technology has continued to double in some metric. I think really there's no other industry other than tech that can sort of lay claim to that growth. And so whether you believe it, maybe you think it's dead, maybe it requires a correction factor, I think whatever your thoughts are, you can't really deny smart devices, IoT, flexible electronics, AR, VR, machine learning. Those are all going to play a huge role in the future. And so our job as engineers, scientists, is to sort of generate the technology that can drive and power those applications. So how do you continue? How do you push Moore's law? At Zynite, we find that solution in the Z-axis. So silicon has done the vast majority of semiconductor scaling along the X and Y plane, but it's running into problems over the last couple of years, thermal distribution, power management, tunneling, and other things. So we're looking to take some of the stress off of silicon by providing functionality away from the front end and towards the back end of line. In order to do this, we're leveraging back end of line active devices, so thin film transistors, TFTs, that can be deposited and patterned to provide active circuitry above the logic layer. So rather than silicon built along the wafer itself, we can stack these TFTs up to different levels and sort of leverage the third dimension to sustain Moore's law. Zynite specifically is working on process technology to enable more aggressive architectures in our chips. So non-von Neumann architecture, chips that combine very different IPs, so image sensors linked directly with logic. And also, we're kind of not the only ones right now. I think every large technology company is also looking to solve some of these problems, but only Zynite's transistor process technology sort of compares favorably in all metrics. So high on performance, breakdown field, compatibility beyond front-end processing, surviving back-end of line temperatures while maintaining high performance, versus some of the main competitors are sort of lacking in one or the other fields. So what are we kind of looking at? What are we kind of doing? Well, we're, as we said, I guess, building devices to complement traditional microchip technology, looking to stitch individual systems together to improve efficiency, whether that be thermal, spatial, economic. But as you sort of might expect, there's challenges in the field. So we face problems in, getting our materials right, abiding by temperature limits, electrical performance, stability, yield. So you sort of, it's such a wide range. When we're looking around, we're not just looking for device experts, design experts. We're looking for expertise over many fields because we have problems in many fields and solutions in many fields. So in general, because it's tricky to pin down sort of exactly one skill or one technology that we're interested in, it's sort of best to just keep it a little general, looking creative people, problem solving, collaboration, communication skills. Those are all super valued here. To give you a little more details, this is our perspective on the semiconductor innovation pipeline. So innovation in the industry is mostly needed from material research all the way up to compact modeling in order to prepare industry for sort of the post-Moore era. LAB2FAB companies, I think the target audience here is mostly, most value is found down in the material research process flow section. But there's a lot of, in that case, there's a lot of value lost by sort of not pushing into qualifying those materials, integrating that process. And some of that is because Canada, I think, lacks the infrastructure. So 300mm R&D capabilities, facilities don't really exist to push scaling. National high volume manufacturing is limited to MEMS devices, other devices, and doesn't really reach the semiconductor field. So one way I think you can sort of see those consequences manifest is looking at how well educated Canadians are compared to how many technologies exist nationally and grow nationally. So I guess my feeling, my perspective is that, at least before Zynite, is that Canada is more hesitant to take a chance on young talent or new technology, especially compared to the States. And so that might make people a little defeated. It might make people encourage people to leave Canada or move away or take a job that doesn't really fit their skill set. But it doesn't really have to be that way. I think Zynite, CMC, the other sponsors are all sort of working to fix this problem. So I guess almost my story, my perspective as sort of a frontliner at Zynite, I get to use my skill set that Canada helped build and develop to break through sort of this barrier into where a lot of value can be found for companies and for investment. So this is one of the reasons why I'm excited to work here. We're not just thinking about building the best process flow and the best new technology. We're also kind of looking towards building the future semiconductor ecosystem here. So we've already modernized, we're modernizing our technology workflow, big data analysis, modern characterization techniques, automated device analysis. So the device throughput that we're looking at right now in terms of testing is huge and growing quickly. And so as we learn, apply new methods, it's always sort of improving regularly, just from my view on the R&D floor. And I think the sense that I have, which is that we're making an impact in the semiconductor industry, is pretty universal here. So this is how Zynite sees the future, and I think we're uniquely positioned to achieve it just because of the enthusiasm, the expertise that we have on the team. So as we break down barriers into these regions, we're going to require expertise sort of at every stage. I would like to end this talk by thanking Jem, our CEO, who prepared a lot of the slides. I'd also like to thank CMC and the sponsors. We believe in CMC's mission in training and supporting a world-class workforce. And I hope you have, after this presentation, a better understanding about what Zynite's doing and how Canada can take part at the leading edge. I hope to share more of our success in Whistler.
So I'd like to introduce Martin Laforêt. He's the director of the quantum strategy for Sherbrooke Quantique Innovation Zone, and he's also runs a deep tech incubator, ASET, a venture capital company, as I understand. He's developed a career in communicating complex topics such as quantum technologies, and recently moved to Sherbrooke to help establish this ambitious ecosystem. and he did his PhD at Waterloo in quantum computing. So, Martin, thank you very much for joining us, and over to you. You're on mute.
Well, you would think after 2.5 years, we would have figured out how to use that, eh? So yeah, I was just thanking you, Ben, for the introduction. Sorry, Lucas, for the introduction, and also all the organizer for inviting me. So the presentation today would be a little bit of a sidetrack, because I'll be talking mostly about an ecosystem that we're building right now in Sherbrooke that will be focused on quantum technology. So just to give you a little bit of context, in February 2022, we got Sherbrooke, which is a couple hundred kilometers east of Montreal, got designated as a innovation zone by the Quebec government. And the innovation zone is sort of the new strategy from the provincial government to make sure that we capitalize on the success of our research and turn the fundamental research into into a growing economy and a growing industry. And in order to arrive to this, we are putting together a bunch of infrastructure and programs to facilitate and remove as many pain points as possible to go from lab setting and into the marketplace. So Sherbrooke has had a long history of research, and I would say, Canada in general has a long history of excellent, academic research, but not so great of a track record when it comes to commercializing those ideas. So the concept of innovation zone is really to concentrate a lot of capital and infrastructure and talent in one physical zone, all around a given theme. And in Sherbrooke, we decided to go ahead with quantum because we have a long history of excellence research at the University of Sherbrooke. For the past 45 years, Sherbrooke has been a hub of excellence in condensed matter physics, mainly in quantum materials. And for the past 15 years, we started expanding our research agenda to go into quantum information and quantum technology. So 7 years ago, we received a sizable grant from the Canadian federal government to launch the Institut Quantique, which is located at the University of Sherbrooke, and which brings together physicists, mathematicians, engineers, computer scientists, even social scientists and business people around the theme of turning quantum science into quantum technology. So with the arrival of the innovation zone, the goal is really to take all those big leap forward in the lab and then bring it towards the marketplace. But unfortunately, this is a whole lot easier to say than to do. There's a lot of major roadblocks and pain points along the way. Often that has to do with access to infrastructure. So this is what we are set up to be. The Innovation Zone is a $400 million project over 5 years, 135 of which is coming from the government, and the rest, over $300 million coming from the private industry. So to build infrastructure. So the first one is it's a building, as simple as an office building. We call it the Espace Quantique. You can think of it as a quantum headquarters, where we're gonna bring in, we're gonna create workspace for startups, more established companies, consulting companies that are all working in the quantum area. It's going to be a 70,000 square feet space. It's actually an old building that we purchased, that we tore down the inside and rebuilt it to make it, an attractive and to the flavor of 2022. So it's going to be co-working space. It's going to be some closed office. It's going to be some conference room. It's going to be some social place. Really a perfect place for work, live, play type of approach. At the back of this office, of this building, because turns out that building is the old newspaper building of the town. So at the back of it, where the newspaper press used to be, it's a perfect place to set up a high-tech lab. And this is exactly what we're going to do. One of the major hurdles for young companies to get into quantum entrepreneurship or in the quantum industry is access to cryogenic and top-of-the-line electronic equipment for controlling quantum technologies like small-scale quantum computers, quantum sensors, quantum memories, that sort of thing. So essentially, a young company needs to go right off the bat, as their first expense, build a $3 million lab. So when you're, a couple people with a good idea and no money in your pocket, it's really, really hard to raise several $millions of dollars when most of which will go into equipment. This is not something that investors are too fond. Actually, no investors are ready to do that. It's way too much of a risk. So what we're going to do is we're going to build a top-of-the-line research-grade facility that will offer dilution fridges, all the electronic stacks needed for quantum control, mechanical room, electronic room, chemical room, essentially everything that you will typically find in a university, but we're going to make it under a rentable model and specifically for companies. So this will be a place where young companies can come and rent space to develop their product without having to spend, to have too many capital expenditure and turn everything into operational expenditure, which is a whole lot more friendly for investors and young companies. Another infrastructure that we're putting together is sometimes that doing the jump from the academic setting into the entrepreneurship setting can be a very steep step. And very often the science is not quite up to par to convince investors to come along in the journey. So we are developing currently a venture studio. And for those of you who might not know the concept of venture studio, which was invented in California in the late 80s, early 90s, think of it as a pre-incubator where the input is not companies, but it's a few people with some ideas and some expertise. And what we do is we offer them a full-time salary. We offer them business coaching, technical coaching. They have access to the technical equipment, and they have 2 years to de-risk the science and the business of their project to then at the end go through a go-no-go step to decide whether it makes sense to incorporate the project and then go off the entrepreneurship venue. So this is a way, again, to massively de-risk the entrance to the market for quantum technologies. Another infrastructure that we're putting together is a quantum internet testbed. So quantum internet is one of those, and quantum communication in general is one of those quantum technologies that is fairly market ready. I mean, I wouldn't say it's necessarily flight tested, but it's more on the, in the TRL 6 and above. But there's a serious lack of testbed around the world. So it works in the lab using fiber optic spool when the conditions are perfect. But there's not a whole place in the world where you can go and test in real life condition using actual telecom network. So this is what we're building all across Quebec, the province of Quebec right now. There's going to be a small network in Sherbrooke, one in Montreal, and one in Quebec City. And then the idea is to offer a test bed where companies can come and either develop and test their product, or even bring use case and clients, and then do some proof of concept on the network with some end user. And this project actually will be is funded, and we should have a kickoff with the first line ready to be used by the end of September. Just want to mention that all of this does not happen in vacuum. There's a whole lot of partners included in it, and especially The partners that are very important are all the microelectronics players that we have in Sherbrooke, like the 3IT, which is a great prototyping facility for microelectronics. There's also the C2MI, which is a prototyping place for packaging. We have partnership with the Institut d'Innovation d'Optique in Quebec and CMC Microsystem, which just like Ben mentioned, I cannot emphasize enough the importance of a player like CMC in the Canadian ecosystem. They offer a service that without them would make a whole lot of young companies not being able to afford services that CMC offers. We have also put together an investment fund to support those startups because you cannot create a startup ecosystem without having investors to help those startups grow and then move forward. And I will wrap up my presentation by saying that what we're trying to achieve here in Sherbrooke is really trying to put together a continuum of ecosystem for the creation, the growth, and the success of a quantum industry, from fundamental research all the way to incubation.
Thank you, Martin. That's really it's so exciting to hear what that Quebec is and the investors are funding such an ambitious project. It's really wonderful. Thanks for taking the lead for this. Brief introduction. So Pinder is the UBC Quantum CoLab Facilities Director. He's an expert in thin film deposition, cryogenic, and UHV design, and building precision instrumentation, such as the ARPAS system, which is he's been managing at the Canadian Light Source in Canada. And he's currently the operations manager at QMI. So thanks, Pinder.
Thanks, Lucas. Thanks for the introduction, and happy to be here. I love the discussion so far. I think I wanted to introduce the Quantum CoLab, and we'll do it really quickly. So I was going to go over a few things, but we'll just skip through a couple of things here. The Quantum CoLab is a professionally run shared resource that was developed for deploying quantum technologies. It's based on 3 institutions that were awarded CFF funding a few years ago in 2015 and 2016. The total funding was about $175 million. And that's strongly supported by a lot of large-scale CFI grants. And the goal here is quantum, and so all these 3 institutions had a proposal that was based on quantum in some form, whether it's quantum materials or quantum-based devices or quantum information sciences, it's to do with quantum. And so in 2019, there was an agreement signed between these 3 institutions, and we formed the Quantum CoLab. And it's a way of providing streamlined access to users to these experts that are housed at these institutions with with high-end equipment. And that combination, I think, has been critical for us to make these programs a success, where you have strong technical support available to anybody that wants to use these facilities. I'm just going to quickly go through the website here. You can get onto the Quantum CoLab website. There's a few links at the top here I'll show you the materials growth link here. It tells you a little bit about what can be done in terms of materials growth. But there's an equipment list down here, and then connect to Quantum CoLab link. And if you go to the equipment list, this is just a UBC part of a small part of the list. We have a complete list across 3 institutions. It's about 6 pages long of information about the kind of tools that we have. And they're color-coded down here in terms of how we use them, whether it's for growth, characterization, device fabrication, device testing, or application. And this is really, I think, a critical resource for people to have a look at. We also would like people to become users of the Quantum CoLab. Get onto our mailing list. We are looking at putting out a quarterly newsletter in the short term here. We're planning a users meeting, and hopefully everybody can join in that. And as we evolve, we are looking for users' input in terms of future tools. So when we apply for grants, what do users need? What does our community need in terms of equipment? Will shape the kind of tools that we look towards acquiring in the future. At UBC, we're very strong on the materials growth and characterization side of things. We revamped all of our nanofabrication facilities. Lucas talked a little bit about his photonics work. It's a few pieces of equipment that are critical here. The E-beam lithography tool, we have a system that can do 8 nanometers. and then the photonic wire bonder. These are relatively unique tools and available to users across the CoLab. Again, I won't go into too much detail here, but we have lots of materials growth and characterization facilities. We have MBE growth of oxides, PLD, pulse laser deposition. We do 2D van der Waals materials growth. We're strongly supported by a theory group that's focused on density functional theory. We have a high performance computer cluster that's dedicated to this. And really that's a strong feedback loop that happens between experiments and theory to be able to produce new quantum materials and understand them. We have 2 beamlines at the CLS that are tailored for quantum materials. And I was part of the QMSC beamline, that's the ARPES beamline, angle resolved photo emission spectroscopy. And then we also have the soft X-ray beamline at the CLS. Again, both of these are tailored for quantum materials, trying to understand them at the electronic level. The soft X-ray beamline, for example, can look at interfaces and look at the physics of interfaces and be able to understand how these things go together. At UBC, we're also developing the Quantum Materials Electron Microscopy Center. We have a new neon stem and a new SEM-FIB that is just coming online. And then we have a bunch of general characterization tools from new Brooker X-ray machines for single crystal and powder diffraction, magnetometry and precision resistivity. So a lot of other tools as well, but really all backed by expert help. That CFF program plus the CFI funding has really helped us secure personnel for long term and be able to share those expertise. So yeah, the Quantum CoLab, if you need more information, you can go and join. You can talk to myself or Kostas Mikalakis, who's the director of NanoFab. The NanoFab facilities are a core part of the Quantum CoLab at UBC.
Let me actually dig up my conclusion slide, because we continue to do this. So there will be our next event is coming up. So we've had, let's see, we've had March, April, May, June. So the next one is, we have July 19th is our next session, and then August 16th. And then finally, we're going to meet in Whistler on September 25th to 27th. So I look forward to seeing you online and in person. And thank you very much again.